A socket is a programming interface that allows two machines, or two processes, to communicate over a network. Think of it as a telephone plug. It allows a connection to be established between a sender and a receiver. In the world of networks, every communication between a client and a server goes through a socket. Understanding how sockets work in Python is a fundamental skill for any cybersecurity professional, because it allows you to build your own network tools, port scanners, service probes, or even simple exploit prototypes. Before diving into code, it is important to understand what a port is and why scanning one matters. What is a port and why does it matter? A network port is a numerical identifier used to distinguish different services or applications running on the same machine. A server can run dozens of services simultaneously: a web server, a file transfer service, an email service, a database, and so on. Each of these services listens on a specific port number. When a client wants to communicate with a specific service, it does not just target the machine's Internet Protocol address, it also specifies the port number of the service it wants to reach. Port numbers range from 0 to 65,535. The first 1,024 ports, from 0 to 1,023, are called well-known ports and are reserved for standard protocols. Port 22 is used by Secure Shell, SSH, a protocol for secure remote administration. Port 80 is used by Hypertext Transfer Protocol, HTTP, the standard for unencrypted web traffic. Port 443 is used by Hypertext Transfer Protocol Secure, HTTPS, the encrypted version of web traffic. Port 21 is used by File Transfer Protocol, FTP, for transferring files. Port 25 is used by Simple Mail Transfer Protocol, SMTP, for sending emails. Port 3306 is used by MySQL, a widely used database system. From a security perspective, knowing which ports are open on a target machine gives you a precise map of which services are exposed. An open port means a service is listening and potentially accessible. If that service has a known vulnerability, an attacker could exploit it. Port scanning is therefore one of the first steps in any reconnaissance phase during a penetration test. The concept of socket in Python. Python provides a built-in module called socket that exposes all the functions needed to create and manipulate network connections. You do not need to install anything extra. It is part of the standard library. To use it, you import it at the top of your script. Import socket. Once imported, you can create a socket object using the socket.socket constructor. This constructor accepts parameters that define the type of socket you want to create. The first parameter is the address family. The most common value is socket AF_INET, which means you are working with Internet Protocol version 4 addresses, the classic format like 192.168.1.1. The second parameter is the socket type. The most common value is socket.sock_stream, which means you want a transmission control protocol, TCP, connection, a reliable connection-oriented protocol. So a basic socket creation looks like this. S equals socket.socket AF_INET, socket.sock_stream. This creates a TCP socket ready to be used for network communication. How port scanning works with a socket. To scan a port, the principle is simple. You attempt to establish a TCP connection to a given port on a target machine. If the connection succeeds, the port is open and a service is listening. If the connection fails, the connection is refused or times out, the port is closed or filtered. The method used to attempt a connection is connect_x. Unlike connect, which raises an exception if the connection fails, connect_x returns a numeric error code. It returns 0 if the connection was successful, meaning the port is open. It returns a non-zero value if the connection failed, meaning the port is closed or unreachable. Here is a concrete example of a minimal port scanner. Import socket. Target equals 127.0.0.1. Port equals 80. S equals socket.socket. AF_INET, socket.sock_stream s.set timeout 1 result equals s.connect_x target port. If result equals 0. Print f port is open.else. Print f port is closed. S.close. Let us break down each important line. Target equals 127.0.0.1 sets the target to the local machine, localhost, which is safe for testing without targeting any external machine. Port equals 80 is the port we want to test. S.set timeout 1 sets a maximum wait time of 1 second before giving up on a connection attempt. Without a timeout, your script could hang indefinitely on filtered ports. S.connect_x target port attempts to connect. Notice that it takes a tuple, address, port, as its argument, not two separate arguments. The result is checked. 0 means open, anything else means closed. S.close closes the socket to free up system resources. This is important, especially when scanning many ports. Combining with data structures and loops. In your previous work, you practiced creating lists of ports and iterating through them. You also built port-to-service dictionaries. These skills connect directly here. A real port scanner does not just check one port, it checks many at once. Here's how you can combine a list of ports with the socket technique. Import socket. Target equals 127.0.0.1. Ports equals 22, 80, 443, 3306, 8080. For port and ports, S equals socket.socket. AF underscore init, socket.sock underscore stream, S.set timeout 1. Result equals S.connect underscore X target, port. If result equals 0. Print F port is open, S.close. This script tests 5 ports and reports which ones are open. You create a new socket for each port test and close it after each attempt. This is the correct approach. Reusing the same socket object without closing it can cause errors. You can further enrich this by using a dictionary that maps port numbers to service names, as you have already practiced. Port underscore services equals 22, SSH, 80, HTTP, 443, HTTPS, 3306, MySQL, 8080, HTTP alternate. For port, service in port underscore services.items. S equals socket.socket. AF underscore init, socket.sock underscore stream, S.set timeout 1. Result equals S.connect underscore X target, port. If result equals 0. Print F port service is open, S.close. This produces much more readable and useful output, clearly associating open ports with the services they likely correspond to. The importance of the timeout parameter. The timeout is a critical parameter. When you call setTimeout1, you tell the socket to wait at most 1 second before deciding the connection has failed. Without this, a scan of a filtered port, where a firewall silently drops packets instead of rejecting them, could cause your script to wait indefinitely. In practice, you should always set a timeout when scanning ports, especially over a network. If you set the timeout too low, for example, 0.1 seconds, you risk getting false negatives on a slow network, ports that are actually open but take longer than 0.1 seconds to respond. A value between 0.5 and 2 seconds is a reasonable balance for local network scanning. Resolving a hostname to an Internet Protocol address. Sometimes you may want to scan a hostname like example.com rather than a raw Internet Protocol address. The socket module provides a utility function called gethosbname for this. IP equals socket.gethosbname example.com print IP. This function performs a domain name system lookup and returns the corresponding Internet Protocol address. In a port scanner, you can use this to allow the user to enter either an Internet Protocol address or a hostname, and normalize it to an Internet Protocol address before scanning. Ethical and legal boundaries. Port scanning is a powerful reconnaissance technique, but it must only be performed on machines and networks for which you have explicit, written authorization. Scanning a machine without permission is illegal in most countries and could result in criminal charges. In a professional penetration testing context, you always operate within a clearly defined scope. In your training environment, always use machines specifically set up for this purpose, such as virtual machines on your local network, and never target public or production systems. This principle will be reinforced throughout the entire course. Summary of key concepts. To consolidate what you have learned. A socket is the programming abstraction used to create network connections in Python. Ports are numbered from 0 to 65,535 and identify specific services on a machine. Port scanning consists of attempting a TCP connection on each port to determine whether it is open or closed. The socket module is built into Python and does not require any additional installation. You create a socket with socket.socket. AF underscore init, socket.sock underscore stream, for a TCP connection. You test a port with connect underscore xhost, port, which returns 0 if the port is open. You must always call setTimeout to avoid indefinitely blocking your script. You must always call close after each connection attempt to free resources. You can combine sockets with lists and dictionaries, skills you have already built, to create richer, more informative scanners. Scanning must always be performed only on authorized targets. This theoretical foundation prepares you directly for building a functional port scanner in the upcoming practical workshop, and for the quiz that will test your understanding of these mechanisms.